Another, see the kinematical question, but it has some touch of energy. Explain what is meant by gravitational potential energy and by kinetic energy. Gravitational potential energy is the energy of an object due to a specific position in gravitational field is called gravitational potential energy. Kinetic energy is energy due to motion is called kinetic energy. Now, a motion sensor is used to measure the velocity of a ball falling vertically towards the ground. As illustrated, the object is falling down. There are two sensors, A and B. The ball passes through point A and B as it falls. The ball has a mass of 1.5 kg. Now, the variation of velocity is given over here. So this is the velocity time graph. Nope, not it is not velocity. Yes, it is velocity time graph. But he's also telling us the position that at 0.4 second it was at A and at 0.8 second it was at used to calculate for the ball its displacement. So how much distance object has traveled? This is A, this is B, and this is a velocity time graph. What you're supposed to do is find area under the graph. So you calculate area from here. Now some students are good with trapezium, so they can deal it as a trapezium, but I want to split it into a triangle and rectangle. So it will become 0.4 multiplied by 4 plus 1 over 2 into 0.4 into, again, this height is also 4 to 8. No, it is not 8. It is 3.8. And it was 3.9. Oops, I made a small mistake. It's not 4. It is 3.9. And the other one is 7.8 minus 3.9. That is also 3.9. So let's find out. 0.4 times 3.9, which is 1.56. The other one is 0.5 multiplied by zero point 0.4 multiplied by 3.8. It is 0.78. So it will be 41312 meters. So 2.34 meters. The acceleration. Acceleration is rise over run. So it is 3.9 divided by 0.4. 3.9 divided by 0.4. So it will be 9.75. Let me check if my calculations are correct. 3.9 divided by 4. Yes, 9.75 or 9.8 into 7 figures meter per second square. So last part of this question, the change in kinetic energy. For change in kinetic energy, we need to recall the information about its mass. It is 1.5 kg. So change of kinetic energy is the formula for change of kinetic energy 1 by 2 into mass into final velocity square minus initial velocity square. So it will be 0.5 times 1.5 times 7.8 square minus 3.9 square. So my calculation is saying it is 34.2. 34.2 or 34 joules. Show that the work done by the gravitational field on the ball as it moves from A to B is equal to change of kinetic energy. Work done by gravitational potential energy will be change of gravitational potential energy, which is equal to mgh. M is 1.5, G is 9.8, and delta H is change of height, which we calculated somewhere 2.34. So it will be 1.5 times 9.8 times 2.34. 34.4. So in two cent figures, actually, if this is how it is, I should change the answer in the previous part as well, which is 34. So it will become 34 joules for this one as well. Hence, shown. Okay. So